what the instruction in the Docker file we are providing to initiate the function of the Docker image, which is intended to be used as the external application. Whether it is run, exec or CMD, what we will use to start the container main application. Hope you have selected the right answer. I am moving further. Okay. CMD is the right answer. Run, and execute is not the right answer, which instruct the Docker that control what the image will do when it starts. So 50% participant has given the right answer and 50% participant has given the... Oh, don't change answer after that. Don't change after. Next question. And this is the last question. What is the command to create a container image based on the Docker file and the source file? We have used Podman, but Podman and Docker both are the drop-in replacement with each other. So you can read this question as Podman run, Podman compile, Podman build, Podman create. What command we will use to build the image from the source file and a Docker file? Hope you have answered the questions. I am moving further. Nice. This is the right answer. Very good. So it sounds interesting. You have attended the session with the attention. Now we are moving to the next part of the workshop, and that is the openshift. So I will use these commands, and one openshift local is already set up on my machine. You can follow the instructions from the official website of the openshift how to set up this application on your laptop or desktop. But thing is that this needs a good enough amount of resources, RAM, CPU, etc. So run this application on your particular machine only if you have a good configuration system. Otherwise, go for the cloud solutions. You can create the OpenShift cluster on any of the popular cloud like AWS, GCP, anything. Red Hat is also providing one sample environment, practice environment. You can go to that also. But before doing anything, please consult the official document of the OpenShift to install and what is the minimum system requirement is required. If it is not fulfilled, then please don't run this application on your very much local system. Docs.openshift is always the right place to get started. Here, read the document based on the version you want to learn or you want to set up, and this guide will instruct you what to do, how to do, and definitely you need a login on the Red Hat OpenShift or the Red Hat platform. So make a user account on this Red Hat platform before installing this application. In the process of installation of local host OpenShift local, that is a single node cluster or the code ready cluster also known. It is known as a code ready cluster, code ready container basically. And follow this instruction to understand what is this OpenShift and how you can install it on your machine. I am moving further. This is my terminal. CRC, code ready container. CRC stands for code ready container and CRC status. So this is showing me the current status of my CRC setup, code ready container setup. It is the virtual machine is in stopped. OpenShift is also stopped, and otherwise the uses of what is, since it is stopped, so there is no uses. There is a command start, CRC start. 10 GB, around 11 GB is already used out of 30 GB available in my machine. This CRC code ready container will take around 1 minute to get properly started. Meanwhile, we can discuss about the what is Kubernetes and how it is important in the cloud environment, cloud application development. So Kubernetes is a primarily de facto standard of orchestration in the containerized world. Kubernetes is developed by the Google and made publicly available for the open source development of this tool. So Kubernetes is an open source container orchestration platform that simplifies the management and scaling of containerized application. So this is the next level of containerization. In the first level of containerization, we took the base image, we copied our application and we build custom image out of it. That is one level of containerization, packaging the host environment, running environment and application in all together in a single image is called the containerization of application. Now we want to make it further scalable and easy management of the lifecycle of the container. For that purpose, Kubernetes is an open source container orchestration platform that simplifies the management and scaling of containerized application. It automates the deployment, scaling, and management of containers, means taking care of health of this containers, scale up, scale down, auto this thing, auto care of health, automatically care of health of the container, making it easier for developers to deploy and manage their application on a large scale. So this is the primary goal of the Kubernetes. So main component of the Kubernetes, we will follow this document. They again try to understand about the topic from their official controller or the owner. So Kubernetes, this is the official website of Kubernetes, that is the kubernetes.io. So we will follow little this application, this page. Meanwhile, our application is going start. It is still starting. So we can use this time to learn about what is this Kubernetes, how it is important, what is the basics of Kubernetes and all. So the main thing of the main activity or main core responsibility area of the Kubernetes is deploying the containerized application on a cluster. So first thing, application should be containerized and intention is to run it on a cluster. Cluster is the collection of nodes. Nodes are the basically resources of compute, resources of storage, resources of networking, resources of load balancer. All these are the cluster. So on this cluster, we want to run a containerized application which can be auto scale and which can be auto healed in case of any node problem. So that is the core responsibility of Kubernetes or core function of Kubernetes. So these are the basic modules, like creating the cluster of the Kubernetes, deploying the application on top of it. We have talked about that container is secured way of application deployment. So everything will be behind the different network segment, behind the network store, behind the different kind of storage. So you have to give some way to use the application, that is the exposing of application, and then scaling up and updating, means whenever we want to roll out the changes, we have made another version of our application and we want to roll out the new version of the application. So all these 4, 5, 6 are the core responsibility or core module of any Kubernetes or Kubernetes tool. Meanwhile, our application is started and we have returned with 2 user ID and password. and one URL. So whenever you are developing, you are testing your application in the OpenShift local, that is the code ready container which is being installed on your laptop or your desktop, you will receive this sample output, and this output is saying that okay, you can you can get the dashboard on the application portal, management application portal, from this URL. And there is a two roles. One is the administrator role and other is the developer role, and two default user ID and password is returned by the system. So okay, what we will do, we can open this portal. So all these are, this is my local basically URL. So when this CRC get started, it managed my etc host entry. So that's why I was able to see some domain name kind of URL instead of some IP address and all. Here it is already logged in as a developer because of the session my browser is having. Earlier I have used this browser to open this particular portal as a developer. And here we can see that there is no resources under this project. So okay, we will discuss one by one with the help of our PPT. So these are the basic commands we will use to work with our OpenShift code ready container or OpenShift local. The new name of this tool is the OpenShift local. OC login and the cluster URL. So when we have started the local CRC start, at the time of completing the starting process, it has returned with one URL, two user ID and password. So we can use our cluster URL, whatever we have used to open the portal or the management console, web portal of the OpenShift management console. That particular very much URL we can use to OC login also, and credentials are already printed on the terminal. After that, there we can create the project, OC create new project, or we can change the project. So for that there is a command OC get projects, and to change the project there is a command OC project name. Inside the project we can create app. So I will just follow up with these three commands first, and then we will move further. So here is the command printed on my terminal, OC evaluate. I can check the OC status. Oh, otherwise first I need to log in. OC login, and it is already giving me one URL to log in to the developer. Now you can see that you have access to the following projects and can switch between them with OC project name. This command is already on our slide also. And what happens if I use a different name, OC login, cube admin. Please focus on this. When I have logged in using the developer role, I have access to the two projects. One is the app management and other is the Ubuntu. But when I have logged in with the admin credentials, password is not asked because I have already used this password to log in here, and that password is already available in my cell session. So now this is showing me you have access to 70 projects. So other 68 projects is basically, many of the project is created by the platform itself for self-monitoring, self-facilitation, etc. I can get the list of project, OC get, project. And you can see that Ubuntu, Tomcat demo, workshop, all these are available here also. And apart from this, we are having many projects with the OpenShift hyphen title. So OpenShift is the container orchestration tool, and OpenShift itself made of different containers. More than 60 containers are running to make this OpenShift environment all together. So OpenShift etcd, OpenShift console, OpenShift config operators, on OpenShift config, OpenShift API server, all these are itself container, and it is here to help you make your application as a containerized application and as a managed containerized application. So that's why it is showing me in the admin section this many projects. Okay, so now we are moving further. I am again changing my role to developer. I don't want to run the application or create a new project in the admin role unnecessary. Developer role is the best choice to create a custom application or running your own application. Admin role should be used for the management purpose. If you want to manage some management level, if you want to do some management level task, then go with the cube admin, and for the other regular activity you should use the developer credentials only. So we have used OC login, OC project name. My current project is app management. Okay, that's fine. OC get pods. This showing me how many pods are running. Typically, we are using one pod, one container. Means in one pod, there is only one container is running. But there is choices. You can create multi-container pod also if necessary. At present, in my particular this view, every pod has only one container running inside the pod. Next is OC new app, and before OC new app, I would like to search the projects. Just like we have searched the images in the podman command, podman search, we can search, one second. OC new app, and then we can provide the source code URL or the container image. This is the syntax. OC new app, source code URL, that is this particular OpenShift is able to build the image from the source code. Means we can provide the GitHub URL, and that GitHub URL will be fetched, build, containerized, and run the container. That is also possible. That is known as here S2I. And we can use, first make the container, test it locally, push the container into the image repository. Maybe it is public, maybe it is private. Then in the OpenShift platform, fetch the container image directly from the repository and run it. So what I will use, These many things we have did already. Podman. Okay, what we have did? We have did introduction, containerization, Docker, Podman, build Docker image, run container. We talked about Kubernetes, and we are now on the OpenShift portal. Okay, that's fine. So we have two approaches. One is the command line approach. Here we can create OC, new app, hyphen capital S, Tomcat. I have put capital S. It means don't run the app, don't create any application. I just want to search it first. I just want to know how many variety of Tomcats I am having. And this is showing me templates. OC hyphen OC new app hyphen template equal to template name. This is the final command we can use, and these are the name of the templates or the name of the images available online. So what the options we are having? To run the Tomcat, we can use this JWS31-Tomcat7 basic S2I. And again, it is the source to image. So whenever we use this template, it will fetch the source code of the Tomcat, build it here, and then run for our use. And most of the things are S2I. Then we are having image, and we can put the image name here, and hyphen code equal to source, which is the optional part. So either we can use the S2I endpoints template name to create the application right from the source code, deploy onto the orchestration tool, that is the OpenShift. Or second option, we can use the Docker Hub Tomcat also. So I will like to go with this option, and this is my command. This is my command. What is my command? OC new app hyphen image equal to docker.io slash Tomcat. Docker.io slash Tomcat. So I am using the image from Docker Hub, that is docker.io slash Tomcat. Run it. So now we are getting response. First response. Platform has found the container from this Docker. And this is a very new Tomcat version, only 5 hours old. Today's latest Tomcat we have fetched. Then it is showing us that I have created the Tomcat container. I have created the service for the Tomcat container. I have created deployment configurations for the Tomcat container. 3 resources. Every component in the OpenShift or the Kubernetes platform is called resources. So 3 kind of resources created for us. Now, success. Application is not exposed. It means still we will not able to view the Tomcat home screen. Why? My application is still not exposed. You can expose service to the outside world by executing one or more of the command below. OC expose service / Tomcat. This is the platform is instructing me. First, I have found the container image on the hub, created 3 kind of resources. One is the image stream, other is the deployment.apps, and other is the service. And then it is running the container, but it is not exposed. So if I am checking OC status, Let me first copy this OC status. It will show me little recent responses that service Tomcat is created, and this is the related to Tomcat. Let's see other command. OC get service. I think SVC will also work. OC get SVC. So this many services currently running in my cluster. One is for my app, other is for his Nginx. I am interested in the last one, that is the Tomcat. So again, service is created, application is running. How I can know? If I run OC get pod. So this many pods are running. Every pod has a application. So you can see that here one pod is running for me, that is the Tomcat. This pod is just created 2 minutes 47 seconds ago. This pod is created. Then I am checking OC get SVC. One service is created just 3 minutes ago. Then I am checking OC get routes. OC get routes. Here I am not able to see any Tomcat entry. That's why our OC create new app, they have responded that okay, we have created the service, we have created the container, we have created the service, but it is still not exposed. It is not available to the public. Internally it is available, but it is not available to the public. How can I know? See URL curl. If I hit this, I am getting some output. But if I am running this command on my terminal or on my browser, I'm not getting anything. Basically, I'm not getting anything. White label page 404 8080. Let me see. 80 on 80 port. I am running the Nginx. Okay, so we will run this command to make it publicly available. What command? OC expose SVC Tomcat. Okay, let me. We have okay. OC get SVC. This is giving me this OC expose Tomcat is running on 8080. So I would like to have 7777 colon 8080 and name of the service. I have to see this. What is this command? This one. OC expose Tomcat. Service / Tomcat. Now I have got the message that one route has been created and my Tomcat is now exposed to the public use. OC get routes. And I got this URL. New URL. If I put this URL on the browser, / so this is my Tomcat. You can see this is the Tomcat 10.1.13. Still this is a empty Tomcat. we have not provided any application to this Tomcat, but we can see, okay, one Tomcat has been deployed for me. One Tomcat has been deployed for me. Now I would like to explain what happened till we have searched for one container, that is the Tomcat, from the public repositories. We have found one container in the Docker hub.com, hub.docker.com. We downloaded that. We have created one application out of it. One application, every application should have service exposed for the internal communication purpose. For the internally microservice want to communicate with other microservice without going to public, we can do this. So that service is available within the infrastructure of our OpenShift clusters. So this is the default. Application should be accessible within the cluster. Application should be able to accessible within the cluster. But few of the cluster application should be able to accessible from outside of the cluster also. That is known as the exposing of the service. 3-step: application creation, that is done; service creation, that is done; and expose of the service, that we have to do separately using the OC expose command. OC expose service/Tomcat. So now we got a new URL. What next? Now the next point is to just map this URL with your some of the proxy server. Either you are having your domain name pointing to this installation, and if this is not the case, then where your domain name is pointing, there you have to set up a proxy server, and you can reverse proxy to this endpoint. You can map this URL in your proxy server, for an example HA proxy server or the Nginx proxy server, and you can made a route, or you can made an route to access this particular URL from your domain name to the OpenShift cluster. Okay, so this is one example. Now come to our slides. So we have did the OC login. We have created the project. Actually, we have not created the project. We have switched to some other project. And then we have created one app, and we opted for the container image. Second part of this command example. OC new app container image name. After that, these are the commands to see what are the components are available and what else we can create. For example, OC get pods. This command will give you the list of all the pods running in your user. Like we have used developer user. So in the developer user, in a particular project, like there is a 2 project, app management and other is the Ubuntu. So I have opted to create a new application in the app management project. So inside the app management project, we have seen that I have lot of pods running, Selenium pods and all. And then OC get routes and OC get services. These 2 commands give me, basically this is not the, this is OC get services. List all the services in the current project. And OC get routes, this command will list all the routes available in the current project. So we have seen all these 3 commands: get pods, get service, get routes. OC get deployment, list all the current deployment in the current project. Again, deployment and expose project is very much similar thing. whatever the project is deployed, is exposed, is known to be deployed also. Then describe. Okay, we will see this OC describe pod, and we will try to check logs of the pod, and then we will try to log in into the running container. So OC get deployment, OC describe pods, logs, and execute pod name. Okay. OC get deployment. So these are the applications currently exposed from my project. We can count the number 1, 2, 3, 4, 5. And what is the output of OC routes? Routes are available for the app, Nginx, and Tomcat. What the app is showing, I think app is showing very much whatever we have seen in our podman. Okay, 1 second. Slash is missing. This is our own project. Okay, no problem. So what is the next command? OC get deployment, OC describe pod. So first we will see the OC get pods, list of pods. This is the pod name, OC describe pod name. So this is the response of the describe pod, and what it is saying, this is the basically output of something like inspect command, docker inspect. Docker inspect will give you how it made up of what is the volume mount, what is the expose port, where it is running, and other details. So when we are exposing this, we are describing this pod. These are basically very much helpful command during your monitoring, bug fixing, overall management of the cluster. So if you want to know what is how this container is made up of, where it container is running, what are the IP addresses, what are the security checks we have applied on this. For those information, we can use the OC describe pod name command. It is saying that, okay, my namespace, my current project name is the app management. Namespace word is used by the Kubernetes guys, and project, the same thing is known as the project in the OpenShift. Whatever the namespace in the Kubernetes, plain Kubernetes, the same thing is known as the namespace in the OpenShift world. So name of the pod is this, whatever what we have given in the command. Then this is the namespace in which project it is available. What is, if any, priority, high order priority is defined or not. Last, when it was started, and what is the deployment name? Deployment name is the Tomcat. Deployment name is the custom name of your deployment. You can put deployment name based on your projects and all. And these are the annotations, means some extra information like where to which Ethernet it is associated. And this is the overlay IP. So this is also a very interesting thing. Docker or Podman or OpenShift, these platform isolate your base operating system network, and they are creating generally overlay in networking. But that is again in the some advanced discussion. We will talk about creating the custom network for our projects, so that we can isolate networking of one project to the networking of other project, Currently, it is just isolated with the host machine IP addresses. For an example, if I am showing you my current IP information, so this is not this one. Yeah, this. My current internet is running with the help of this IP segment 192.168.31.252. That 31 is my routers, my Wi-Fi routers network segment, and these are the virtual network segments created by different virtualization tools I am using. Like this is for the virtual box, and this one is the networking of my code ready container virtual machine, CRC. You can see that all these are the different network segments. But on top of it, we can create different network segments for the different projects inside the OpenShift container, code ready container. Okay, leave it for now. So this is the network segment for my this particular namespace, this particular project, and you can see that it is a basically SDN. SDN stands for software defined network. So it is nowhere in the physical, or it is not persistent on the host machine. This is a very much virtual internet IP address which is created by the OpenShift software defined network, SDN. Now move further. So this is the Tomcat container. This is the container ID. This is the basically image ID of my local image repository. And this was created from this image. This is the image ID of the hosted Docker Tomcat image, which is hosted on the docker.io. So all these are the output of the describe. I want to know what is the IP address or the local IP address being used by this container, how this container was made up of, from where it was gets downloaded or I have retrieved this image, what port it is listening inside the container, and then few other details, Kube API access. These are the internal details of the Kubernetes which is available to this pod or this container. And then these are the different values, key value pair, which is showing me how this was get started, successfully assigned, what are the events take place during the execution of or rollout of this application on the OpenShift. So all these are the basically information we got from the OC describe pod name. We got from the OC describe pod name. Now next is OC log command. OC log command is used to get the running log from the container. So I just want to see first OC get pod. It is showing me list of pod. This is my pod name, OC logs and pod name. Again, OC logs -f we can use to see all the logs getting generated in the real time. So without f, it will just scroll all the logs and terminate the command. But if I put -f, generally we are using the tail command also, tail log -f and then the file name. So it will keep on running, and whenever there is new line get inserted into the log file, it will display here also. So OC logs give me opportunity to see the running log of the Tomcat container. And we can use this command with the podman also. Podman logs -f container name from the podman ps command. So podman ps command will give you the list of all running containers. From there, you can use the container name or the container ID to see the logs of the container. If it is running through the podman, you can see get the logs from the podman logs. And if it is running through the openshift, you can get the logs from the oc logs command. After the oc logs command, we can go inside the container using the execute command. Again, this is the same as we have worked with the podman execute. We have executed podman exe -it and then podman container name and then -cell, something like this. So instead of now my container is running inside the openshift crc code ready container. So I have to use the oc openshift command line tool, oc command. Now you can see that we have landed to this location. kubectl execute pod command is deprecated and will be removed in the future. Use kubectl exe pod -command instead. Pod command is okay. One hyphen is added in the new version of the command. No problem. Still it is working. Only warning is there that in future you should use double hyphen in between the pod name and command name. So this is the my containers terminal. This is not my machine terminal. This is the container terminal. Okay. So what we have achieved till we have created the application, we have exposed the application, we have seen the application running, and we have described the pod to see how it was created and what kind of IP addresses and other details it is being using. And then we have seen the logs of the container using the oc log command, and we have dived into the container terminal also using the oc execute command. Now we can manage all these things, whatever we have practiced so far through the terminal. We can manage all these activities through the admin console panel also. Through the admin console panel also. Where is that panel? This is this panel. One second. Let me close few tabs. You can see that what is the status of my machine. Okay, this is the terminal of the container, and this is so out of 30 GB, 32 GB, 29 GB is already used. I am running out of memory. So that's why I should close few tabs before going further. Okay. Oh, I got 1 GB free. Thanks. So this is my so graphically you can see that this many application is being running on my project. Selenium Hub, Chrome, Tomcat, Nginx. What is this? Selenium Firefox, My App, Selenium Python, and Selenium Python 2. Leave it. Here we can see the details that this Tomcat is currently running. We can view log here also. So all these things we have checked. This is the terminal. So this is diving into the terminal. This is the OC execute command basically. It has become little slow. This is the matrix. Okay. But I want to see the logs. Logs are not coming because nothing happened. And it is showing you the trail of the logs. Next action, what I would like to edit the pod. Okay, this is the basically describe command. Not from here. One second. Edit pod count. From here, I would like to show you how easily we can scale the application. Currently, I am running one instance of my Tomcat. Suddenly, I just want to increase my instances of Tomcat from 1 to say 10. Save it. And if we go to the terminal and we see OC get pod, see here 10 instances of my Tomcat is created. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Last 5 digit is the short name of the very much container. And before that, this is the name of the image which is used to make this container. So you can see that from the same base image, 10 installation of the Tomcat is just created. And if on the terminal, here you can see that all 10 pods are available. 10 pods are available. Okay, 10 pods are available. This is the describe command output. So this is the container base image taken from the docker.io, and 10 deployment instances has been created very quickly. So I'm running 10 node of Chrome pod, 10 node of Firefox pod, 10 node of Tomcat pod. And beauty of this platform is this all Tomcat is being served using one single URL. Load balancer capability is by default added to the Tomcat cluster. Otherwise, if we were going to set up this Tomcat cluster at our own, then certainly we have to put one reverse proxy in front of all these 10 Tomcat, and we have to set up the upstream and then do the configuration and restart of the reverse proxy software so that it takes effect. And similarly, if we are just removing one Tomcat out of it, then again we have to change the configuration and we have to restart the front reverse proxy application like Nginx or the HTTPD, anything, HAProxy, etc. Here, all of a sudden, we have just increased the number of pod count from 1 to 10, and it gets replicated. It just gets replicated like a magic, and we have not to worry about the load balancing. We have not to worry about the configuration of the your proxy servers. Everything is set up by the platform itself. What about if I want to change the count from here also? Very easily from the graphically we can change the number of counts. Okay, load has decreased. Now just run one pod. That's fine. Now see here, get pods. Only one pod is remaining. So this is the beauty of the OpenShift container platform, or any Kubernetes or any orchestration tool which runs the container. Orchestrating, scaling up or scaling down is a very easy job for this kind of platform. Now I would like to demonstrate you the auto healing part. For any reason, if this pod get deleted, if for any reason this pod get deleted, suppose OC delete, OC pod delete, I think OC pod delete or OC delete. Now, okay, unknown command rm for OC. So OC has delete command. One second. OC get pod. So this pod is running. If I'm 0 scale to 0, then what happened? Okay, scale to 0 can be happened. Okay, we have not set up the retries, and we have not set up the minimum this thing. So we can scale to 0 also. Again, we are creating more pods to serve our Tomcat application, and it gets created. So we have seen that managing the instances, scaling up the instances, scaling down the instances is a very easy job in the OpenShift cluster or the Kubernetes orchestration for the containerized application. So for the base, if your application is containerized, if your application is tested on the Docker Podman, then you can take this application in any of the image repository. Maybe it is public or it is private. And then you can take those images from the repositories and run on the OpenShift cluster or the Kubernetes cluster. Here you can see the replica set, pods running, environment in which it is running. So many things are there. Okay, now I would like to demonstrate little of this OpenShift dashboard. So what kind of information we can get from this dashboard? Otherwise, all this information we can get from the commands also, like OC describe command, OC get command. So here we are having two major view of this dashboard. One is the administrator and other is the developer. In the administrator, you can create new projects, and this is one operator hub. Operator hub is a marketplace. Just like in Maven, we are having Maven Central, or in Eclipse, we are having plugin repositories, Eclipse Marketplace. to get the plugins of the Eclipse IDE. Similarly, we have certified images and applications repositories supported by the Red Hat in the form of operator hub. And here we can see the installed operators, what kind of operators is installed on my machine. So if I go to the developer mode and then add, and in the, this is the altogether way to get the applications to run on my cluster. So for that I am having developer catalog, Git repository, container images, sharing from the local machine. We can upload jar file, we can upload configuration file, and many more options are there. So first I will go to the developer catalog. So these are all the softwares, applications, solutions available on the marketplace. And this is a very big list. Beauty of this operator hub is that all are certified images. Certified images means Red Hat has a way to certify all the images for the security concerns. So these are the very much secure certified images. Not to worry about security and compatibility things. All these images are very much tested for the compatibility with the OpenShift container platform, and you can use any of this. For an example, what I would like to see, any application you want to run on this. MariaDB, Nginx, okay. Node, PHP, Postgres. Let's run this Postgres. Initiate template, app management. These are the namespace from where it will get downloaded. Database name, sample DB. Okay, done. OC status. See here, Postgres service in the running. Okay, OC get pods. This one is pending, means it is working on. Postgres deploy is running and Postgres instance is pending. After some time, again this is the same condition. It will take some time because it needs resources, it needs RAM. What is the status of this Postgres? It is pending. We can view the log here. Status is still pending. One node are available, insufficient memory, preemption. Oh my god, I don't have enough RAM to demonstrate this. One sec. What I can do, I can remove a few things. This will release few memory for me. Container creating, still it is creating, it is not complete. Delete pod. Using the UI we can delete the pod. Using the command also we can delete the. What about my Postgres? What is the health of the Postgres? It's still running. Okay, Postgres is running. And what is the health of this Tomcat? Tomcat 2 is running. Okay, so it means my Postgres is deployed successfully. My Postgres is deployed successfully. Let me check. OC get SVC. This service is created. Postgres is running on my cluster. Postgres is running my cluster and OC get routes. It is not exposed. So to expose this, what I can do, OC expose, expose service tomcat slash postgres. Okay, for that Postgres, we need to make some entry in this pgconfig and postgres.config file. So accessing Postgres from outside is not easy job. No problem. At least we can go inside the container and see the OCget pod. This is my pod name. Okay. OC execute -it pod name cell. This is my this thing. PSQL -l. This is my sample DB. Connect sample DB. Create table ABC ID int name char 20 table created insert into ABC values 1 comma Ambarish select star from ABC slash D. So I have demonstrated you that very easily we can create a Postgres database, and I got this Postgres database from the operator hub. From where I get this database image? From the operator hub, which is the UI portal of the OpenShift local, and this is the signed container repository by the Red Hat. From there, we have installed, we have got one container. We run this container in our OpenShift cluster, and we are able to log in into the container. We are able to create some table, some database. This sample DB name itself, from where this sample DB name came in the catalog, when we use this Postgres, see, I am not running again it because I am running out of memory. Postgres. So we have used this template, and in the template you can see that this sample DB name was the initial database name given in the template itself. So that's why this database name came here. We can change the name in the template, or we can create new database by the logging into the Postgres SQL instance. And now the matter of this how you will able to connect this particular container database from very much your application or from other computer in the network, that is different story. That is the Postgres management part, which is not the part of the OpenShift at all, but we can manage the networking kind of thing also to make it more available to the cluster or to the network. Okay, so all these things we have discussed, and what left? 1 second, let me check. One second. Okay, so we have talked about the OpenShift portal. We have discussed about the OpenShift basic command. OpenShift like OC create new app, SVC, get SVC, get routes, describe pod, OC logs, OC execute. All these are the basic command to interact with the OpenShift cluster at regular basis. Okay, we have not seen this. That is all. This is available on my GitHub page, and instruction is given there. If you will able to create your local environment on your machine, then please go to this GitHub repository. You can go there also first. So this is my GitHub repository where I'm regularly posting new projects, whatever we are discussing in our different workshops and discussions. So here recently I have created one this repository, for Ambris, King of Kubernetes, and in this you will get one Selenium Hub practice. So you have seen in my OpenShift portal, you have seen there is a lot of Chrome instances, Firefox instances. So all these can be built from here, and I have given full set of instructions to easily work with your local OpenShift platform. And if you continue with this tutorial, easily you will be able to run all these YAML files, and you will get ready with your Selenium cluster. So this is the Selenium hub used for the centralized Selenium testing. So developer or the Selenium tester or the CI/CD pipeline can be integrated with this Selenium hub, which is hosted on the OpenShift code ready containers, and it will give you the idea. So this is the CRC status, CRC start, which we have just run in the beginning of this session. And then just log into the cluster using your developer user ID and password, which is shown on the terminal during the first start. And then simply you can create the projects or you can create the applications using the YAML file also. So inside the YAML file, you will provide all information, what the service you want, from where you want to download the image, what kind of port you want to expose. So every information will be provided in the um, configuration file, that is the YAML file, and OC create -f. Instead, we have demonstrated that you can create new application using the OC new app, and then you can provide -f image and then URL of the image repository, or -f source and URL of your source repository. So this is the two way of creating application, and this YAML file version is the third way of creating the pods or creating the applications in your OpenShift cluster. So one by one, if you run all the commands from this repository, first clone this repository, go inside the folder, change the directory to the repository folder in your computer, and one by one run all these applications, and you will be land up to this point. How? So up to this we are creating, then we are exposing, and then we are doing the port forwarding. After the port forwarding, you will be able to access the Selenium Hub dashboard. This is the Selenium Hub dashboard where you are seeing this. Okay. So this is the third way of creating applications, and you can get this repository from my GitHub account on the public. So this is for the, okay, now we are moving here. So you can do this, tag the custom, this is left, get three things are left. No problem. Any question till now? So how this session for you, is it useful for you, or it is the just waste of time?
No, no, it is useful for us.
So actually, thing is that Kubernetes or cloud or this type of platform is very common nowadays. So definitely, one day you have to come to this type of environment, and you have to start working with this type of solutions. So why not from today? When tomorrow this is the reality, then prepare for today only.
Right.
है ना? So, and one more thing, whatever the area we are working means this is the software engineering. So, just like in medicine, doctor, or in just like in law, working advocates, they are always saying we are practicing. Means, if you are talking to a doctor, Doctor Saab, how is your practice is going on? Doctor is not going to work or not going to duty, he is going to practice. Similarly, engineers are also now in the practice mode only. Every time we have to learn the new things, new software, new way of working, new environment. So we have to be in the learning mode all the time.